Welcome to video 1.3, and in this video I'm going to look at setting up mouse controls, an optional choice for if you want your ship to use the mouse to target where it rotates towards, which gives you a little bit more accuracy, so it overall makes the game a little easier. But I find it a very enjoyable way to play Asteroids, as opposed to purely going with WASD controls. So instead, the ship will track wherever the mouse cursor is on the screen and turn towards it. And so that's going to be neat. It'll open up a lot of options for us. If you choose to down the road, maybe you don't want the ship to track the mouse, and instead you want to give a turret on the ship that tracks the mouse, so the ship can fly in one direction and shoot the other direction. You would be able to see that from the code that we do in this lesson. Alright, so this actually isn't going to require us to do anything inside the Unity editor. All this is going to be handled inside of the script. And so not much has changed since we were last here. But what we're going to do is add one extra variable up here so that we can optionally toggle the mouse. And let's introduce another way to do this. So let's just put it up here. Well, let's put it, yeah, it's a moving variable. So we're going to call this private bool, so it's a Boolean variable, true or false. Use mouse controls equals false. So this is going to be the default setting. So the default setting is that mouse is not going to be used. But this is a private variable, and so that means it's not going to show up in the editor. But the standardly accepted way of making things show up in the editor is to use the serialize field command. If you use serialize field, even with a private variable, it allows it to appear inside of the Unity editor. So you can see, after it finishes compiling it, you can see that inside of my ship, I now have this toggle for use mouse controls. And so I could turn that into an option that might show up in some kind of menu. But right now I'll just manually I can manually turn it on. All right, so going back to our scripts. So let's go adjust our movement controls here to use the mouse controls instead, or optionally rather. So what we'll do is we're going to say on this one, we're going to go with use mouse controls equals false, and there's input. So I mean, if you want to be a little bit cleaner with your code, you can do this, where you can say if not, use mouse controls and input. So either one would be fine. So if you're not using the mouse controls, then it uses this. We can then do else. Let's do an else if. Use mouse controls. And I suppose I need to put some comments on my ending methods since these are getting quite large. I'm just going to put some comments on here. So that we can have, I mean, there's lots of comments, but it's going to help us stay organized in the long run. All right, so if we are using mouse controls, then let's take a look at how we're going to actually handle this. So the first part of it is a little bit kind of intense, because we're going to have to convert the mouse's location to essentially a two-dimensional space, rather than trying to do any sort of weird ray casting. So we'll start with a vector 3 called mouse position. And that is we're just going to gather it from the input dot mouse input dot mouse position, not whatever it was trying to autocomplete there. And so this gets the location of the mouse. But let's turn it into a computable position that we can use. And so that will be a vector 3. And we'll call this target. And what we're going to do is turn it into a coordinate that's relative to the screen space. And so this is kind of a weird command. We'll do camera.main, accessing the main camera, screen to world point. So it turns it from being a position on the screen to being a point in the world that the ship could try to track. And so we're going to set that to be a new vector 3, where we use the mouse position's x as the x, and we'll use the mouse position y as the y, and then the z will be the camera main near clipping plane. Might need to switch the locations of that, but we'll see during playtest. Some other things we need is, I guess I probably don't need those there. If we needed to gather like the amount of pixels on the screen, you can access that pretty easily just by doing screen.width and screen.height. All right, so let's actually get the mouse to turn, or to get the ship to turn to this mouse location. So let's go inside of the target here. I guess I should probably just swap this around like this. So we're just setting the positions to be this. And then we're going to do with quaternion, call it target position. So this is kind of the, or let's call it target rotation. This is going to be the rotation that we want to achieve as a result. And we can generate a quaternion out of, we can figure out the rotation by comparing my current position to this target. So we're going to say look rotation targets minus my current position. So this actually handles some of the trigonometry for you. This look rotation command is going to figure out the it's essentially a vector, the difference between my position and the position that the mouse is in. Actually, rather, it's the mouse's position minus my position, so that we can figure out where it needs to be. If you want kind of a more visual interpretation of that, let's kind of think about it in MS Paint. So let's say that my ship is here, and the mouse cursor is right here. What this is basically doing is it's taking the target, which is the mouse's position, and subtracting my x and y. So it's essentially figuring out this angle. I actually draw my triangle right. Like that. So it's figuring out the angle from my ship to that position by doing that operation. And so we've calculated my target rotation, and now we're going to actually use the physics command. Well, we'll use the transform dot rotation equals quaternion dot rotate towards, and so this command is gives it a time frame. So this allows us to not make it instantaneous. The ship will slowly rotate towards it from my current position, transform dot rotation, to the target rotation. We get to define the speed, and so we'll do turn speed times dot delta time. So let's see if that's too fast, too slow. We might have to actually adjust it. So it should control how we rotate towards the player. So let's hit save, and let's see how this works. The script should automatically update. We've got our use mouse controls checked, so it's compiling it right now. The console does not report any errors, so we should be good to test it. And so I've kind of got something a little bit messed up with it. As you can see, the ship is rotating in some strange directions. So I think I may have computed the math. So let's swap this around on line 66. Going back to how I calculated the target, we'll change it to this, X, Y, and Z. And then I'm going to go and, before I do all this, I'll change the Y position of that target to be my Y position. So the ship's Y position. I think that's kind of the computational mistake I made. So what this is doing is it's actually grabbing the Y position of the ship, which is the height amount. And so that should fix this problem. So it compiles, and then we go back to testing it, and we should see that it tracks the player ship, the mouse, pretty well. So now when we move forward, we move towards the mouse, and my A and D keys no longer have control over it. So this is an alternate way to kind of handle movement, which it's an interesting approach. But it might be more enjoyable if you're trying to go for a little bit more accuracy when you're attacking asteroids inside the game. And so that's where we will conclude this video. Here's the updated code for it. At that last moment, I did tweak this part, adding the target.y, setting it to the ship's height, which would explain why it was pointing in weird directions. So if you need to update any of your code, just freeze the frame on here. But that should be mouse control for the player, and thank you for watching.